Hi, so I'm going to go over some of the information for the power lab that was outside on the bleachers, and then just a few more things that will be really helpful for the big fun that you have coming up. So the first part, I'm going to talk to you about some of these equations. And so really you should write these down on the sheet that I know you can use, and that will help you with your assessment. So we have velocity, which is distance over time. And the unit for that is going to be meters per second. So everything that you've done in this unit, those were the units you used, meters and seconds. Acceleration is velocity divided by time. So again, you've used meters and seconds. And when you see it in a problem, it will have the unit of meters per second squared. You also have force, which is mass times acceleration. And the unit for that is newtons. Work, which is force times distance. And the unit for that is joules. And again, distance is going to be meters, right? And anytime that you do that in these assignments. Finally, you also have one power, which is joules divided by time. Joules you find here, and the time is going to be whatever the time is that you were using. And the unit for that is watt. So again, take a second, pause this, write these down. These are going to be key for your assessment. Okay. So the assignment that we did, the lab, kind of looked like this. So we started, you talked about your weight, and you converted that to kilograms. I made up some numbers to use for this assignment. And then there was also a question here where it said weight in newtons. This one is the kilograms right here is what you're going to use for the rest of the calculations. And then when we were outside, we said that the stairs were about 0.4 meters. We want to make sure that you have that 0.4, because that's going to be important for your calculations. And there were 12 stairs. So 12 stairs times 0.4, 4.8 meters. Again, your numbers may be different. I think maybe we did 4.1. I rounded everything to the nearest 10th for this whole thing just to make it easier. So now I've got a distance. That's going to be the distance that I use in the rest of my assignment. Times, made them up. These were kind of where people were. Again, in seconds, everything to 1/10. The average, add up all 5, divide by 5. I came up with 3.38, which was rounded to 3.4. Again, yours will be different because your times were different than these. So now there were 3 things that happened real quick here. We want to know the velocity. Well, the formula for velocity is distance divided by time. So here's your distance, that we calculated earlier, your average time, and then this was the answer that I got to the nearest 10. Acceleration, and notice up here where it says meters per second, that's just giving you the unit. Acceleration, velocity divided by time. So the velocity that we just got, which was 1.4, divided by the time, which is still 3.4, same time. Force, mass times acceleration. Well, here's my acceleration that we just found right here. My mass from before was 68.2 times 0.4, 27.3 newtons. Okay. The very bottom, energy, joules, equals force times distance. Well, here's the force I just found. Distance, same as the beginning, going up the stairs. And my calculation was 131 joules. Again, yours will be different because your force is going to be different. On the back, this was an opportunity to do more practice, but basically to find the watts, you have the joules times the seconds. So we had 131 joules times 3.4 seconds which is what the answer is here. Yours will be a little different. How long could you keep a 60 watt light bulb lit? Well, if I have 445.4 watts divided by 60 watts per second, and I come up with 7.4 seconds, right? So again, you can pause, go back, kind of look at this, but this will help you make sure you understand the lab. Then for this assessment, these are a couple of definitions that will be very helpful. Again, those equations are going to be helpful. And these definitions, an elastic collision. So when objects collide and there is no loss of kinetic energy, they just kind of come together, maybe they bounce off, but the energy is the same and they keep moving. For inelastic, objects collide and some of the energy is changed to either heat or sound, okay? Those are the definitions that will help you, and then you'll be able to answer some of the questions. On the Big Fun, you're going to need to know how to use those equations and these definitions. Hopefully that will give you a really great start. You'll have a good understanding.